Hello everyone, I'm Ning Tang from UCLA and Zhejiang University. A three-time Prime Minister of UK, robustness, had described English policy in the following sentence. Despite all the political implications, it revealed an essential fact. Agents live in a world rich in physics. Agents interact with physics to achieve their intentions. Sometimes they take advantage of the physical system by doing nothing. Sometimes they fight against the physics for their goals. Apart producing actions from the first-person perspective, humans are also trying to explain others' movements from the third-person perspective in terms of physics and mind. In this video, there is a circle, a static square, and a mass of dots. When watching this video, many observers reported the circle is fighting against a flow of obstacles to reach the square. One viewer said it was me to catch up the emails but failed. When agents interact with physics, the observed motion is complex. It brings challenges for perceiving the agent's intention. One is that the agents are not omnipotent. Agents sometimes even get pushed in undesired directions, resulting in large deviations between intended paths and the actual motion tracks. Here is another example of perceiving intention with physical constraint, a leash dog example in the cartoon Tom and Jerry. Not only in cartoon, it also can be observed in the real world. The deviation is also large in this example. Besides the deviation, there is a line connection to the dog, showing it is not independent. Its autonomy seems lower as it is now a part of a larger system. The question is, how can we perceive intention of a physically constrained agent? Intuitively, we can do that. However, the current psychological evidences predict that we can't, because either one of the large deviation and the line connection can disrupt the perception of intention, not to mention that they are now combined in one single scenario. I will quickly review the psychological studies of perceiving tracing here. First is about the deviation. In one study, the tracing subtlety is manipulated. It controls the maximum deviation from heat seeking. In the 0-degree condition, the wolf always heads to the sheep. In the small subtlety condition, the wolf moving direction is uniformly sampled from a 60-degree window. Also, the subtlety can be 90-degree like this. Subjects need to identify the wolf and the sheep in a display containing 4 moving objects. It is really hard to perceive the tracing intention when the deviation is large. Here is a demo when the deviation is 45 degrees. Here is the ground truth demo in which the sheep and the wolf are colored with green and red. We can see the tracing here when they are labeled. The result shows that the identification accuracy of pointing out the wolf and the sheep drops dramatically as the subtlety increases. In other studies, the objecthood of the wolf and the sheep is manipulated by connecting them to other objects with lines. So the autonomy is decreased here. Here is a demo. With the line connection, the tracing intention is also becoming harder to perceive. Here is a ground truth demo. We attribute the fragility in the perception of intention to the arbitrary nature of the physical disruptions introduced in these studies. The deviation is arbitrary without any reasons. Also, the connection is arbitrary. It connects two objects that don't belong to our physical system. While in the leash dog example, we can perceive the intention with intuitive physics. The deviation of the dog is caused by the physical constraint from a leash. The line connection has its physical meaning, represents a physical system that the dog is in. When the deviation and the connection are explained away by the physics, we can perceive the intention. So here we propose a joint inference framework of physics and mind for understanding agency in physics. In this model, there is a physical system and a mind. Here we refer the mind as the belief, desire, intention model and focus on the intention in this study. Agents produce actions according to their mind, following the rationality principle. Then the physical system and the action are putting together into the general equation of motion. The equation of motion describes how the acceleration of a physical system caused by forces. Here we highlight two components of this equation. The first one is the control force. Here we want to point out the action of an agent is a control force to control its body for achieving its intention. In the leash dog scenario, the dog applies a forward control force for reaching the cat. Another one is the constraint force. When an agent applies a control force, a constraint force will be generated, so the motion will not break the whole system. Also, in this example, when the dog pulls the leash forward, the leash will react back, generating a pulling force to draw it backward. So after inputting the physical system variables like mass and gravity, and the action from the agent, a corresponding constraint force and acceleration will be outputted by solving the equation of motion. For vision, only the motion information such as velocity and acceleration can be observed directly. So the task of vision is to jointly infer the physical system and the mind that can best explain the observed motion. When inferring the latent causes of the motion, vision needs to consider all the possible combinations of physics and mind for the observed motion. For example, now the dog is static. There are a wide variety of combinations for explaining this state. Vision looks for the best one, so it can perceive the leash system and the chasing intention. The reason why the inference has to be a joint process is there is a V structure in Bayesian network. Based on the analysis of causality, the physics and mind are independent when nothing is observed, but they become dependent when the motion is observed. So there is a mutual interaction between physics and mind. When the perception of physics is disrupted, the perception of mind will also be disrupted. For example, when the connection is arbitrarily linked to another object that is not in the physical system, the constraint from the system is disrupted, and it becomes harder to perceive the intention. The effect of the opposite direction also exists. Breaking the mind perception will also disrupt the perception of physics. When the sheep is invisible, we can't feel the intention. It will also be harder to perceive the physical constraint. So in this study, we test our joint inference framework with a leash wolf display. In this display, there is a sheep, a wolf, and a master. The wolf and the master are connected through a leash. Each agent has its intentional action that expressed as the control forces. The sheep applies an escape policy to run away from the wolf, and the wolf is chasing the sheep. The master is pulling the leash to stop the wolf. Also, there are constraint forces for the agents from the physical system. The wolf is constrained by the leash, so the composed force is like this. Also, the master is also constrained by the leash, and the composed force is like this. We apply the multi-agent reinforced learning in the physical engine module code to train the agents in physics. and generating the displays for experiments. First, we test the prediction that disrupting physics will disrupt the perceived intention. We conducted a subjective report experiment first. We asked the participants to describe this video to its friend. Here is the leash wolf display showed to the subjects. In a disrupted leash condition, the connection is between master and the sheep. Here is a demo of disrupted leash. Then we check if there is any word related to tracing in the subjective reports. The results showed that when the leash system is disrupted, spontaneous report of perceived tracing intention is also disrupted. We also conducted an experiment to objectively measure the performance of tracing detection. To increase the search difficulty, a destructor that moved randomly was added. Subjects needed to identify the wolf and the sheep from the four objects. In the disrupted leash condition, the connection is between master and the destructor, who actually don't belong to the same system. Here is the demo for the leash. Here is the demo for the disrupted leash condition. Besides the master destructor pair, we also set the conditions of connecting all the other possible pairs. This is the performance of the wolf master pair condition, which is the normal leash condition. When we use an arbitrary connection that links either the sheep or the wolf, the performance drops. In all the 5 conditions here, the wolf or the sheep is connected, so they are not independent. But the physically meaningful connection makes perceiving intention easier than the other 4 connections. The most interesting result is from the master destructor condition. Based on the objecthood study, now neither the wolf and the sheep are connected. They are both independent objects. It should be easier to perceive the tracing. However, the performance is still lower than that of normal leash condition. The results show that the objective detection of tracing will be disrupted when the connection has no physical meanings. Then we test the effect of the opposite direction. Here we disrupt the perception of intention by making the sheep invisible. A destructor was added in the display. Now we check the words describing the system in the subjective reports. The results show that disrupting intentional action also disrupts spontaneous reports of an intuitive physical system. We also test the objective capacity of identifying the leash. The connection in the master wolf condition is a real leash, but the connection in the master destructor condition is not. We predict subjects can well distinguish between them when the tracing intention is normal. But it will be harder to discriminate when the perceived intention is disrupted in the tracing absence condition. We asked the participants to determine the type of the line connection. When they detect a leash, they were also required to identify which one is more actively fighting against the constraint. Here is the result of correctly detecting the connection in the master wolf condition, and also identifying the wolf is more constrained one. It showed disrupting the perceived intention can also disrupt the perception of physics. Last, I will show some pilot results of Bayesian modeling for this joint inference framework. Here is the demo. The thickness of the lines represents the properties of a leash connected between the objects. The colors of the objects represent the properties of the different identities. The conclusion is that vision is jointly influencing the physics and mind. Thanks for listening.